Problem 8.17 tells us that a helium gas cylinder has a volume of 180 liters and a pressure of 2,200 psi, which they're nice enough to convert to ATM for us, 150 ATM at 25 degrees Celsius. And they ask us to determine the number of moles of helium as well as the grams or the mass. So whenever we're going to plug into a formula, we want to clearly identify all of our variables. So our pressure, 150 atm, volume 180 liters, R, since I'm given pressure of atm, I'm going to say 0.0821, that's my R value I'll use, atm liters per mole K, and then we're solving for N. And then our temperature, we've got to convert from Celsius to Kelvin by adding 273.15 to the degrees Celsius, so get 298.15 Kelvin. And then to solve for N, we divide pressure times volume by RT. So the first thing I want to do is I want to make sure that my units cancel out. And I just want to point out, here are my units for R, atmosphere liters per mole K. So let's see what we got. My units of atmosphere cancel out. This is my pressure in my numerator, and then pressure here from my R value cancels out. And then liter, my volume in the numerator, and then volume down here from my R value cancels out. And then if I extend this fraction bar for my R value, my K cancels out because K divided by K cancels out. So every unit cancels out except for moles, but it's in sort of a funky place. If we look at our units only, our units end up being 1 in our numerator here, divided by, that's this fraction bar right here, and then 1, which is what the units in the numerator of the R value cancel out to, per mole. So 1 over 1 over mole. So we can rewrite that as taking our first fraction bar here to task by writing that as a division symbol. So 1 divided by 1 per mole. So when we divide fractions, we know that we take the reciprocal of the second and then multiply. So 1 divided by 1 over mole is the same as equal to 1 times mole per 1. And so we see how our units end up being moles. So that really is the trickiest thing of that problem, is making sure that all the units cancel out except for moles. So when we do that, the calculator does our hard work for us. We get 1,103 moles, which is a lot, but helium doesn't have a lot of mass, so it's actually possible to squeeze a lot of helium into a tank. And if we change those moles to mass, we do that by multiplying by the molar mass, and there are 4 grams of helium for each mole of helium, and we get 4,412 grams, or your textbook may put it in kilograms, 4.412 kilograms.